Hello there. In this video, I want to talk about, is it possible to divide two matrices? And the reason why I asked this question is because I want to know, we can add them, we can subtract them. It's natural to wonder, can we divide them? The answer is technically yes and technically no. We don't think of matrix division in terms of being division. If we think about division, I can take a number 8 and divide it by 2, and I would get 4. Or I could take 8 and multiply it by 1/2 and get 4 all the same. This would be multiplying by the inverse that we're dividing by. And that's how we're going to look at matrix division. We're instead going to look at it as matrix A and multiplying it by the inverse of the matrix that we would be dividing by. So in this video, we're going to look at how do we find those matrices, and we're going to start small like we always do. We're going to start with a 2x2. Now, the determinants, that whole series of videos that I had around determinants was important because we need the determinant to solve for the inverse. Okay, so let's really quickly remember how to do that. That was we multiply the crosses, so cross multiplication in a sense, and we get 1 times 4, and then we subtract that, minus 3 times 2. We get 4 minus 6 equals -2. And if you go back and watch my 2x2 determinants video, this was the same problem and the same answer that we got. That's how you start. Now, how do you find the determinant? It's actually pretty easy when it's 2x2. Everything's easier when it's smaller. So the first thing we're going to do is we're going to take this matrix and we're going to switch 1 and 4, okay? So I'm going to rewrite a new matrix. I'm going to switch 4 and 1. And then 3 and 2, I'm going to keep them where they're at, but I'm going to make them negative. -2, -3, and we're done. Just kidding. Of course we're not. We're going to multiply, because this is where the determinant comes in. We're going to multiply by 1 over that determinant, okay? And now this becomes scalar multiplication. Scalar multiplication with matrices, you can just distribute the scalar into the matrix and multiply each number. So I'm going to get -1/2 times 4, which is -4 over 2. I get -2 over 2 here. I get -3 over 2. Sorry, -2. So -2 over -2, -3 over -2, and 1 over -2. And then all we have to do is simplify. So I get -2, 1, a +3/2, and a -1/2. So that is the inverse. Now, how do we know it's an inverse? Well, think about an example, and I'll actually modify the example from the beginning. If we take 8 and divide it by 8, we get 1. Or, again, we could take 8 and multiply it by 1/8. We get 1. When we take a matrix and multiply it by its inverse, we get the identity in return. So really quickly, let's recall that the identity of a 2x2 matrix would be 1, 0, 0, 1. So if we go ahead and multiply these two together, I'll set that up. I'll try and squeeze that in. 1, 2, 3, 4 times -2, 1, 3/2, and -1/2. And I'll actually remove some of this work so that I have more room, because I have the inverse written down. Okay, so let's go ahead and multiply. We take this row times this column. And I'm just going to do the work in my head. 1 times -2 is -2. 2 times 3/2 is 3. So -2 plus 3 is 1. So far, so good. We're going to go ahead and multiply by this column now. 1 times 1 is 1. 2 times -1/2 is -1. So we get the 1 plus -1 is 0. Awesome. Now we're going to take this row and multiply it by this column. 3 times -2 is -6. 4 times 3/2, well, that'd be 12 over 2, 6. So we get -6 plus 6. We get a 0 here. And then we multiply by this column. We get 3 times 1 is 3. 4 times negative 1/2, that's a negative 2. So we get 3 minus 2 is 1, and it checks out. All right, let's go ahead and finish the video with the last example I had in the 2 by 2 determinants. Let's go ahead and refresh that one. That was 2 minus 2. So 2 times 1 minus 1 times 2. That gives us 2 minus 2, which gives us 0. Now, you might already be spotting a problem, but let's see it through to the end. Let's go ahead and set up our inverse. And we will switch this and this. So I got 2 and 1. And then we'll make this negative and this negative. So negative 2, negative 1. Not bad. But then we have to multiply by 1 over the determinant, which is 1 over 0. We can't do 1 over 0. We can't divide by 0. That was a whole video unto itself. So this inverse does not exist. This 2 by 2 has no inverse, which will demonstrate for future sake that not all matrices have inverses, and specifically not all square matrices have inverses. Much is the same where only a square matrix can have an identity. Only square matrices can have inverses, but not all of them do. And it will be specifically when you're looking for the determinant, and this determinant also acts as a check. If we get 0, it has no inverse. If we get anything other than 0, then it will have an inverse. If you like this video, go ahead and give it a like and subscribe to the channel. And if you want to see more videos and have an idea, go ahead and leave it in the comment section. And I will see you for the next video. Thanks for watching.